Hi guys, welcome to my YouTube channel. So for this week, I'm going to explain to you how you should answer all the quiz questions for chapter 1. So let's get started with the first question. Question number 1. The pressure of a gas is reduced from 1200 mmHg to 113,324 Pascal as the volume of the container increases by the movement of a piston from 85 ml to a certain volume. Determine the final volume of the container if there is a 695 Kelvin increment of temperature with an initial temperature of 90 degrees Celsius. So the first thing that you need to do is you need to look at the unit that is given to you in the question. So if you can see here, the unit of the pressure is given to you in mmHg and also in Pascal. So in saying that, you need to convert this to ATM. So 1200 mmHg is equivalent to 1.5789 ATM, whereas 113,324 Pascal should be equivalent to 1.1184 ATM. Okay, so this one you can either use your calculator or you can calculate it manually. So what is the next step? You need to be able to decide what formula that is suitable to answer this question. So since you were given the pressure, volume and also the temperature, so the best formula that you need to use is P1 V1 over T1 is equivalent to P2 V2 over T2. Since all of the other information is given to you already in the question, so we can just plug in the value. Right now, let's go and calculate the value of the final volume that we want. So initially, the pressure that we have is 1.5789, the one that we have calculated just now. So 1.5789 times your volume. So the initial volume is 85 milliliter. So make sure that you need to convert this into liter. So 85 divided by 1000 divided by the initial temperature, which is 90 degrees Celsius. So 90 degrees Celsius, you need to convert that into Kelvin, so 90 plus 273. So we are going to do the same thing for the other side. So the initial pressure, the one that we have calculated, is 1.1184. Then the final volume is the thing that we want to calculate. And if you can see here, there is a 695 Kelvin increment. This is not your final temperature, but it is actually the increment. So the increment from the initial temperature. So 695 plus 90 plus 273, right? So make sure that you don't get this wrong. So from there, we can move on to calculate what is actually the initial temperature and also the initial and the final temperature. So 1.5789 times 85 divided by 1000. So this one, the temperature is actually 363. And on the other side is 1.1184 times your final volume that you want, and actually the final temperature is 1058 Kelvin. So now it is very easy for you to calculate your V2. So your V2 is equivalent to 3.91153 times 10 to the power of negative 1 divided by 1.1184. Therefore, your V2 should be equivalent to 0.3497 liter. Right. So in the choices of answers given to you in author, the answer should be in milliliter instead of liter. So what you're going to do is you just need to times 1000 over here. Therefore, your V2 should be equivalent to 349.7 liter. So just bring this 1, 2, 3. So you get it 349.7 liters. So this is the final answer for the first question. Alright, let's move on to the second question. An unknown sample with a mass of 2.3 times 10 to the power of negative 4 had a volume of 78.5 centimeter cube at 95 degrees Celsius and the pressure of 102 kilopascal. Determine the relative molar mass of the unknown sample. Alright, so just as question number 1, we need to look at what are the values that is given to you so that we can choose what are the suitable formula that we can use for this question. So you were asked to calculate the relative molar mass. So basically in gas law, there's no other thing or no other formula that is suitable to calculate the relative molar mass other than the ideal gas law. So ideal gas law is PV equivalent to nRT. Right. So what are the information given to you in this question? So the first thing that you need to look at is you need the pressure. So given to you the pressure is in kilopascal. So we have 102 kilopascal. So you need to calculate and convert it to ATM. So it's equivalent to 102 times 0.009869. So you should get 1.0066 ATM. So you can go ahead and put this value over here, 1.0066 ATM, and the volume given to you is in centimeter cube. So 78.5 centimeter cube. So centimeter cube is actually equivalent to milliliter. So you just have to divide this with 1000 to change it to liter. So you should get 0.0785 liter. So you can go ahead and plug this in, 0.0785 liter over here. So it's equivalent to your N and your R. So remember your R for gas law is 0.0821 and your T, what is your T? The temperature is 95 degrees Celsius. So you write that 95 plus 273 because you need to convert that to Kelvin as well. So from here we can just press our calculator and we should get 790.1810 is equivalent to N times 30.2128. So therefore you can get your N by dividing this. So 790.1810 divided by 30.2128. Hence you will get your N equivalent to 2.6154 times 10 to the power of negative 3. So your N is actually the number of mole. So but in the question you were asked to calculate the relative molar mass. So since you were asked to calculate what is the relative molar mass, because you only have the number of mole, so you need to use the best formula, which is N, which is the number of mole, is equivalent to mass over RMM. So in order for you to use this, you need to make sure what is the unit for your RMM. So always remember the RMM should be always in gram per mole. Right, so now we need to plug in all the value that we have. So the number of mole, which is N, is equivalent to 2.6154 times 10 to the power of negative 3. So this is equivalent to the mass. So given to you, the mass is in kilogram instead of gram. So 2.3 times 10 to the power of negative 4, you need 2 times 1000 to convert it to gram, and you need to divide with your RMM. So the RMM is the thing that you want to calculate, so you need to rearrange this formula. So your RMM should be equivalent to 0.23 divided by 2.6154 times 10 to the power of negative 3. So you should get the final answer is 87.9407 gram per mole. So this is the final answer for your second question. Moving on to question number 3. An ideal gas has a volume of 10 liter at 20 degrees Celsius and a pressure of 750 mmHg. Provide an expression to determine the volume of the same amount of gas at STP. So the first thing that you need to do is you need to look at what are the information given to you in the question. So you were given the volume, the temperature, and also the pressure, and you were asked to calculate the volume at STP. So naturally you should know what is the best formula to use for this question. So if you've been thinking of using the formula P1 V1 over T1 equivalent to P2 V2 over T2, then you are absolutely correct. So since you were given the pressure in mmHg, so naturally you need to convert it to atm. So the best way is to divide this with 760. So 750, which is the value that given to you in the question, divided by 760, then your V1 so has a volume of 10 liter, so your V1 is 10, and the temperature is 20 degrees Celsius, so naturally you need to convert this to Kelvin, so 20 plus 273, so equivalent to the final pressure. So the final pressure is at STP, so STP, the pressure shall be 1 atm, and the volume is the one that you want to calculate, and the temperature at STP is 273. Right now, so we just need to rearrange this calculation. So you will get your V2 divided by 273 is actually equivalent to the whole set here. So 750 divided by 760 times 10 divided by 293. So we are going to bring this one on that side. So V2 is equivalent to 750 over 760 times 10 divided by 293 times 273. So we can rearrange again this into V2 equivalent to 10 times 750 divided by 760 times 273 divided by 293. So the unit shall be in liter. So this is the final answer for the third question. We are now at the fourth and the last question for the quiz. So question number 4, a 600 milliliter container holds 2 moles of oxygen gas, 3 moles of hydrogen gas, and 1 mole of helium gas. The total pressure within the container is 760 torr. What is the partial pressure for the oxygen gas? So the first thing that you need to do is you need to find the mole fraction for oxygen. So now we are going to calculate the mole fraction for oxygen. So what is it? What is a mole fraction? So the mole fraction is actually equivalent to the number of mole of the thing that we want. So now we are going to look at oxygen gas. So the number of mole of oxygen gas is 2 mole. So divided by the total number or the total amount of moles for the gases. So you have 2 moles for your oxygen plus 3 moles for hydrogen and another 1 mole for helium. So you get 2 divided by 6. So equivalent to 1 over 3. Right. This is your mole fraction, but in the question you were asked to calculate the partial pressure. So what is the partial pressure? So what is the partial pressure? Is mole fraction times the total pressure. In this question, the total pressure given to you is 760 torr, and indeed if you look at the choices of answers given to you, is in torr as well. So definitely you do not need to convert the 760 torr to ATM. But in case you were asked to calculate it in ATM, so you need to convert it beforehand. So for this question, the mole fraction that you have already calculated is 1/3, and the total pressure given to you in the question is 760 torr. So definitely the final answer for this question is 253.3333 torr. So this is the final answer for the fourth question. Alright guys, so this is the end of this week video. I hope this video will help you to understand more on the first chapter. So I'll see you again next week. Thanks for watching. Stay safe and take care. Goodbye.